All right, we got kinematic equations here. Yeah, here I come. Here we go. Second season of Part C on Demand again. Kinematic equations. All right, here's the situation. For this year, and this is 2015, the first challenge science class, you're going to have a week to do this, okay? And we've never done these before. But I think it's a good reinforcement to help you understand the idea of physics, where you see what you're given in a word problem, you list what you have, you plug in what you have, and you solve for what you need. So I think we're going to do these problems. Again, it's the first time I've ever done them here in this class, here in the 8th grade here. But I think it's important, since you guys have done such a great job with free body diagrams and everything else, and you're really starting to see the idea of look at what you have, look at what you need, how am I going to get there? What I mean by that is, look at your givens, here's what I have to solve for. What formula do I need? This is something that reinforces that. And it's done again at the high school level. But I think it's important that you practice this. Just the idea of problem solving in physics and reinforcing what you've learned. This actually goes back to the first chapter, and I was a little hesitant on doing this with you. I didn't think we could do this, but given the success of the free body diagrams and the amount of material you've understood and mastered so far, I think we can try this. So I'm filming it in about a week or so. You're going to be given a quiz on this, and since it's our first time, I'm not going to cram that you memorize 4 formulas in 1 week. I will give you the formulas for this, but you've got to be able to do the problems. I want you to try it, and I think if you watch the video, we'll do some practice on here. There's how many? 8 problems on here. I'll go through 3 of them, and there's more practice on physics class, and I'll provide more practice. You're responsible on your own, and you're going to take a quiz of about 5 to 6 problems, probably worth about 30, 40 points each, and see how you do. Okay? But I'll give you the formulas. I won't even make you memorize them, because this is the first time we're doing it. Never done it before. Why not try something new, but also reinforce the concept of being neat, being organized, and learning how to take a given. And hey, Miss Camilleri, what's up? She's
Hi.
Visiting. Hello. You're live on camera.
Hello, camera.
Hello, hello, hello. What are those things? We got free clipper things over there. All right. But anyway, we want to reinforce the idea of good problem-solving habits in physics and reinforce what you've learned. Okay, so pretty much kinematic equations are going to reinforce the concept of acceleration. We learned about acceleration being Bf minus Vi divided by t, change in velocity, delta V over time. But we're also going to add the component of distance in there too, and see how far things travel given acceleration. Okay, just to take it one step up and see how you do. So you should have this paper, and on here you've got the 4 different primary kinematic equations. We broke it down. Use this certain formula when you're given these values, and you don't need this. Okay? So we've organized it. And also, I want you to understand, if you go to higher level physics, they may replace the variable d with the letter x, which just means delta x change in position. And when you change position, you travel a distance. Is that clear? So just keep that in mind overall. So let's just take a look at the first problem. Let's try to see how it goes. And I want you to watch how we solve this. These are easy actually, but require organization. So we're going to start here. A race car starting from rest accelerates uniformly at a rate of 5.2 meters per second squared. What is the car's speed after it has traveled 200 meters? Okay. So you look. Let's think about your givens. What are the obvious givens? You write down every variable, VI, VF, D, A, T. One of them you're not going to need. Okay? And when you take a look at this, and keep in mind, this is my first time doing this, teaching this, so be easy on me too. So we have here, we have an acceleration, so that's obvious. That is 5.2 meters per second squared. We've got, looks like a distance, and that's unit recognition of 200 meters. And it looks like, what is the car's speed after? To me, it sounds like we're solving for final velocity. So we don't have a time, so I would put an X there. Time is not needed. Put an X there, okay? Which means not needed. And it looks like our initial velocity is going to be 0. And that sometimes makes the problem easier. So you've got initial velocity, you're solving for VF. You've got a distance, you've got an acceleration. The time is not needed in this problem. So put an X there, meaning not needed. So when you go up top here, and I don't know if you'd have to memorize these in high school or not, I don't really care. I just want you to get practice. What formula has all these values where you don't need time? And that formula is going to be this one. BF squared equals vi squared plus 2ad. Okay? And they want you to solve for vf right here. So everything is over here is just fine, but here's what you got to look at. Let me ask you something. What is your vi value? 0. So look at this. This is 0. So write the formula here. But what does this formula then become? Vf squared equals, what's 0 squared? 0. This becomes 0 right here, because 0 meters per second squared is 0 plus 2ad. So our formula is Vf equals 2ad. You see how easy that becomes? Oops, Vf squared. And we'll get rid of that squared. You know what to do. We'll take the square root. So now over here, you plug it in, plug it in. How easy is this? So Vf squared equals 0 squared. This is 0. We have nothing there. What's 2ad? 2 times the acceleration. What's the unit for acceleration? 5.2 meters per second squared. Please put your units, everybody. Units, units, units. Let's sing that song again, because I know certain people like to forget that. That's okay. Let's sing it. 1, 2, 3. Every number has a unit, yeah, except for what? Except for what? You don't know about this one, mechanical advantage. pH. But what else? We just learned it! You know what it is! But we're not working with that now. Excuse me. So anyway, it's 2 times 5.2 meters per second squared, because that's the unit, times 200 meters. And when you take 2 times 5.2 times 200, you get a VF2 value. And this is where your work comes in at 2,080. Now, this is just you doing the math on the side. We don't know what the unit's going to be yet. So then how do you isolate VF by itself? You want to get rid of this. You want to move it over here. So it becomes VF equals the square root of 2080. And you know your final answer is going to be meters per second. You know your final answer is going to be meters per second. So the final answer for that is going to be VF equals the square root of 2080 meters per second. It's going to be 45.6 meters per second is your final answer. Okay? So, take a look at it. The car accelerated at a rate of 5.2 meters per second squared. Over 200 meters. It's a pretty significant distance. Okay? You started at rest. Your final velocity, right, became 45.6 meters per second. So again, when you have a 0 value here, it cuts your problem down considerably. And when you solve for VF2, remember this exponent comes over here and becomes the square root. And that's all you're left with. So it's a pretty easy calculation. But again, you have to look at what you see and go from there. Okay? So the final answer is 45.6 meters per second. Okay, now I'm going to do the next one. Where's my eraser? Here it is. So watch this. I'm going to erase this. Keep your variables here because that's what you're working with. Here's your box where you come up with the formula and isolate the variable. There you plug it in, and here's your answer. Not bad, huh? Shouldn't be. If you've been practicing. Next one, an astronaut standing on the moon drops a hammer. If the hammer falls 6.5 meters vertically in 3.4 seconds, what's its acceleration? Okay, what are the obvious variables that you obviously have? 6.5 meters vertically, distance. Okay, you also obviously have time, 3.4 seconds. You also obviously are solving for acceleration. Okay, so you're solving for acceleration, so you know acceleration is Vf minus Vi divided by t. Now hold on to that thought, but you're given distance. The astronaut is standing on the moon, drops the hammer. If the hammer falls 6.5 meters vertically, what's its acceleration? Okay, so we need to know its acceleration. Can you figure out final velocity from that? Not at this point, you don't need it. You just need to find out the acceleration. So watch. What value can I derive out of this? Is that object moving? No. What is its velocity at this moment? It's at rest. Yes. 0 for rest. So our VI is going to be 0 meters per second. And that might ease up the problem a bit. Okay? So you've got VI, you've got D, you're solving for A, you got T. So there's your 1, 2, 3, 4 variables you're going to work with. Therefore, put an X through that because VF isn't needed in this problem. Okay, so which formula shows me I don't need VF? and I need d VIAT. It looks like the third one on the list there. So d equals VIT plus 1/2 AT squared. Okay? So let's take a look at that for a minute. We got to solve for A. Oh no. We got to solve for A. Uh-oh. Hey, algebra crew. This is where this algebra comes into play. I'm assuming people in geometry, this shouldn't be hard for you. Algebra, I don't think it should be hard for you either. Let's see what happens. Okay. So let's just take it one step at a time. Let's plug in and see what we have. We have a distance of 6.5 meters. That's great. Just to play around with it. Wait a second. What's my VI? Yes! Yes! 0 meters per second times time. Oh my gosh! Yes! What does that mean? 0! Woo! Yeah, buddy! 0. See how that becomes 0? So your formula has gone down to 1/2 AT squared. You see how that works right there? Okay? So now you're left with distance equals 1/2 AT squared because this value is 0. This, anything times 0 is 0. Is that clear? So get rid of that. See how easy this becomes? But here's the situation. You've got to solve for A. Oh no, guys, that's really hard. So how do we isolate the variable to get A? Over here I've got a fraction, 1/2. When I bring it to the other side, it's no longer a fraction. It becomes 2D, okay, equals AT squared. I need A to be by itself. So you bring this whole thing down over here. So you divide on both sides by T squared. Oh, bingo. These cancel out. So you've got 2D over T squared equals A. See how that works algebraically? Okay? Man, I love those 0 problems right there. That makes it so much easier. Okay. So A equals 2D over T squared. Now, can we work with what we have here? It looks like we can. So now plug it in. Watch this. A equals 2 times 6.5 meters divided by T squared. Okay, watch this. 3.4 seconds squared. Well, what am I squaring? Just that. That doesn't mean anything. Make sure you parenthesize it. Okay? So now that when you calculate that through, the acceleration is going to be 2 times this divided by this squared. 2 times this divided by this value squared. And when you do that, the answer should be about 1.12 meters per second squared. Now, every number has a unit, yeah, except for coefficient of friction, mechanical bench, pH. And there's probably more that we haven't even learned yet. So, let's see. Does every number have a unit? Yes, yes, yes. Yes, yes, yes. The acceleration rate was 1.12 meters per second squared. So we started at rest. It traveled only 6.5 meters, so it didn't travel that far. Okay, it didn't travel that far in a short amount of time. So to go from rest to 1.12 sounds pretty logical. Okay? So that makes sense right there. All right? So take a look at that one. And you know what? I'm going to do a fourth one for you. I'll even do a fourth one for you. So far, so good. All right? So again, if you see a 0, man, look at it. You just break that up right there. Makes it a lot easier. Okay. One more. I'll do a fourth one. Okay? All right. Hulk Hogan and Randy Savage. Oh, yeah. They were called the Mega Powers, I think, back in the day when they were a tag team back in the day. Back in the old WWF. Hulk Hogan and Randy Savage are playing miniature golf. Randy Savage's golf ball rolls into a long straight upward incline with a speed of 2.95 meters per second and accelerates at 0.876 meters per second squared for 1.54 seconds. Determine the length. Okay, so this is going to be something we've got to determine. You've got to solve for D. So we got a time of 1.54 seconds. Okay, so now here we go. We have long straight upward incline with a speed of 2.95 meters per second. That is going to be, you ready for this? This is going to be your, oh sorry, we got acceleration here, 0.876 meters per second squared. That is going to be your VI, 2.95 meters per second. We got to solve for distance. We don't need this value right here, VF. Okay? So now the formula we're going to use is this. D equals VIT plus 1/2 AT squared. Now add up. Of course we have an initial velocity, so I can't make that 0. But the trade-off is I'm solving for D. So I want to keep this formula. This formula is fine because if you look at it again, I'm solving for D. I have an initial velocity value. I don't have VF, don't need it. I've got a time value. I've got an acceleration value. So this is a simple plug-in. So over here we go, d equals vi times t, so it's going to be 2.95 meters per second, right, times t of what, 1.54 seconds, right? There's your first half of it so far, and that answer right there gives you, and we'll do one piece at a time, 4.543 meters right there to start. What's the rest of it? 1/2 at squared, so then you're going to go plus 1/2, the acceleration is 0.876 meters per second squared, okay? Times what? The time squared, what's the time squared again? 1.54 seconds squared. So when you do that, this right here, half this, square this. This is almost like kinetic energy. Remember, half this, square that, except the variables are different. This will give you plus 1.038 meters. When you add these together, you would get a value of approximately, my distance equals 5.58 meters traveled. That's the length of the incline. So again, here you're solving for d. You plug in everything across. It's simple math. Multiply these two, you get this. Look at this, meters. These cancel out. Then half this, square this. There's that. Add them, there's that. Very simple equation. Okay, man, we got some famous people in here. Number 4 is Sixto Lezcano, former Philly. Manute Bol, former Washington Bullet. They used to call the Bulls before the Wizards. Then he was a Sixer and then a Golden State Warrior. 7'6" player. And I think that's it as far as the celebrities are concerned. There are a couple other ones which get into acceleration due to gravity. Okay, so keep in mind what the value is. Use 10, don't go 9.8. All right, try these, see how you do. I wouldn't work on these until after the tests. Make sure you're done the chapter 2 first before you get into these. But I'll have this up on the video. All right, there we go. See how it goes. Once again, we keep plowing through. Send the message. Challenge science. Look where we're at. Look what we're doing. Look at how much we've accomplished. We've only just begun too. It's going to keep growing and growing and growing because we keep shattering how much we've been doing. Last year we did a lot. This year we're doing more. We keep doing it. It just keeps happening, and it's outstanding. So there you go. But again, you will be given the formulas. I don't think it would be fair that I made you memorize those 4 in a whim. Now, if you want to, go right ahead. You're not getting extra credit for it. But if you want to, you can. But I wouldn't. Even I'm saying this. Don't worry about it. I'll just give you the formulas. But I'm not going to write down for you. Use one you have and not needed. You got to figure that out. But I'll give you the formulas. Absolutely. And try them. There's stuff on Physics Classroom. In the next couple of days, I'll try to come up with another worksheet where you can do more calculations. All right. Learn on your own. There you go. All right. Have fun with it. Be ready. There we go. Kinematic equations, signing off. Man, we shouted out Hulk Hogan. We shouted out. Oh man, that's a horrible view. Hopefully you guys could see that. Here, I'll zoom in on that a little bit. There you go. Okay? Any questions, let me know. We have help desks. We got everything else. Okay, signing off. Bye.